Hi, welcome to my channel. It's Mr. Day Lover once more again. And we're talking today about stations, one of the sections of the Cameroon GCE physics practicals. So, stations have four short experiments that you're expected to carry out. And each of these experiments, you're expected to process your data and report it in 10 minutes. So in total, you have 40 minutes for this section. And make sure you use your time wisely. You make the mainstream should be done for 1 hour, stations for 40 minutes, and use 20 minutes to check your work. And in this section, in your reporting, you have a diagram to draw, you have procedure to write, observations to make, you have an inference to do, you have calculations, conclusions, and precautions. So I will take you through each of these sections, and then we'll go through examples of different experiments and how to report them in this format. Okay, let's go. Now, procedure. Yeah, you're just stating what you did to carry out the experiment in point four. Don't give instruction. I repeat, don't give instruction. Don't tell measure this, clamp this, or attach this to this. No, the clamp was the spring was attached to the clamp like that. So you have to what you did. Don't give instructions. Make take that. Observations can be qualitative or quantitative, and make sure that it's fall around your five senses of see, feel, smell, hear, and taste. What did you see in the thermometer? I saw a rise of the liquid in the liquid column from this to that. You did not see temperature rising. You saw the liquid in the liquid column rising, or the height of the liquid column changing. That's what you saw. They gave you a multimeter, an ammeter. You saw numbers. You see. So what you see, what you felt, what you heard, a pop sound. That's what. Don't say things that you did not see. For example, you say, uh, I observed a temperature rise. What made you to know there's a temperature rise? That's what we want to know in this section. You saw that there was a temperature, yes, but what caused you to know that there was a temperature rise? Because you saw something rising. That's what you saw. So temperature rise, it's like you're inferring right now. It's like inference. It's not. It's not your. Um, it's not what you saw. So what you saw should base on your five senses. Take note of that. Okay, inference now is why the observation. Why what you saw. For example, we will observe that there will be a rise in the liquid column from 25 degrees to 27 when using a shiny metallic foil, and a rise from 25 to 32 when using a black piece of cloth. That's what we have observed. Why was there a rise from 25 to 27 when using a shiny metallic foil, and why was there a rise from 25 to 32 when using the black cloth? You want to give reason now. So there was a rise from 27 to 25 to 32 using the black cloth because there was more heat flow. There was a more heat transfer. More heat was transferred from whatever source to the bulb of the thermometer, and less than when it was using the shiny metallic foil. So that's what we talk about inference. Now you're explaining why there was a rise in temperature. Okay. Now also make sure I always want to know that inferences will always in your report booklet, in your answer booklet, they always give you various sections. The section for you to write the procedure, the section for you to write the inference, observation, conclusion, and everything. So in experiments that have inference on it, note that the observation must be qualitative, or it can be qualitative and quantitative, but there will be qualitative aspect in it. If there's no qualitative aspect in it, if your observation is mostly quantitative, means that it's make mostly of information like I said T1 was equal to this, T2 was equal to this. Know that you will not have inference in the next section. You will just have calculations. So take note of that. So inference goes mostly with qualitative observations. Okay. Now Calculations. Now, these calculations, they'll ask you to always calculate, you always go respect to what they want you to determine, whether it's density, whether it's the power of a lens, whether it's current, whether it's energy, and lots more. So you have your formulas, you put them, and you have to use the information in the observation, the quantitative data that you collected in your observation to do the calculations. Now, precautions is for you to tell what make you help you to do the experiment better. And many students always do this as precaution. I carry out the experiment twice so that I can have accurate results. But if you say that, make sure your observations should be able to back up that precaution. For example, if I say I repeated my experiment, I did it twice, it means that in your observation, I should see like T1, T2, and T average. I should see L1, L2, and L average. It should be evident in your observation. If it's not, then that precaution is wrong. So you need to make sure you do that. And when you're doing main stations, don't collect many data. Just say collect one info data is okay, or collect two in the case of accuracy, or for you to so you can be to write have a precaution to write. So we the T1, T2, and then T average. Make sure you collect at least two values or at least just one. Don't go and taking three values because you have just 10 minutes to do that experiment. Conclusion is very simple, and it goes directly with your title. If my title was, for example, to compare between good good absorbers and reflectors, good absorbers and good reflectors, they come to your conclusion. Like for example, shining 4 is a good reflector of heat and poor absorber of heat, and poor absorber, whereas black cloth is a good absorber and poor reflector of heat. Or for example, if they ask you to determine the density of the experiment of an object. You just get from the experiment, the density of this object is this. Or if they ask you to determine the power of a lens, you say, from the experiment, the power of the convex lens was this. If they asked you to determine the current or the voltage of a certain resistor or a battery, you said that from the experiment the voltage was this. That's all. That's about your conclusion. So conclusion is very short, straight to the point, and you don't need to write much, and it always carries 1 mark. So that are the main sections of a station. You have a diagram, you have to draw, you have a procedure, stating points, you have um, observations. The observation can be qualitative or quantitative, and if it's qualitative, you have an inference to do. The next stage will be inference. But if there's no inference, it means that you have just quantitative observations, which the next thing will be calculations. After the calculation, you have precautions to write, and then you have your conclusion to make. And that's all for stations. Thank you so much for listening. So the next video, we are taking a sample example and we analyze each of the stages and how to answer them. Thank you and keep watching. Bye-bye.